Right, and now we look into question 5. They say sketched below is the graph of the function f of x, which is ax squared plus bx plus c, and g of x, which is d to the power of x plus q. Right, they give us the coordinates there of a, right? So we know a is -3 and 0. I'm just going to put that there. And b would be 1 and 0. And they say these are the x-intercepts, and c, we know that it would have the coordinates 0 and 6. So we know that the value is 6 over there. In fact, I can even write that as 1 and that as -3 over there. Okay, right. Now they say to us the graph of g passes through the origin and the point 1 and 2. So at some point there, we will have the coordinates 1 and 2. That is for the graph of g. Right, now the first thing they ask us to do is use the graph to determine the values of x, where f prime x. Now remember, ladies and gents, when we're looking at f prime x, we're looking at the gradient of the graph, or in this case, we can even say whether the graph is going uphill or downhill as we go towards the right, okay? So we are looking at the gradient, okay, of f and g of x. Now, in this case, g of x, we are looking at whether the y values are positive or negative. Now, they say f prime x times g of x less than 0. Now, when do we have something that is less than 0? That is negative, right? So either when we've got f prime x positive and g of x negative. Now let's look for that solution. F prime x being positive means I am going uphill, right? Remember, the graph of f is going uphill. Where is it going uphill as I go towards the right? So it is uphill over this area over here, right? But it should be at the same time where g of x is also negative, right? And you'll see that g of x is actually negative all the way up until we get to the origin. So that means our solution would be from negative infinity. The graph of f of x is f prime x is actually positive, right? It's going uphill from negative infinity. The graph of g of x is negative from negative infinity, okay? And all the way up until, all the way up until the turning point of f, okay? So our first solution here, okay, is x is an element of negative infinity until the turning point. Now, what would be our turning point? It would be the midpoint between the two x-intercepts, right? So that's -2 plus 1 over 2. That would be our turning point. So that would be, all right, that would be -1 over 2, right? Actually, I made a mistake there. That's -3 plus 1. So that would give us -2 over 2, and which is -1. So, which means the turning point there would be the point -1. So our solution would be from negative infinity until the turning point of f, right, which is 1. Now let's swap these around, where f prime is negative and g of x is actually positive, right? So where is f prime negative? From the turning point all the way till infinity, right? It is going downhill, right? And then g of x is actually positive from 0, okay, all the way to infinity. So then our next solution would actually be from 0, okay, all the way till, let's see, want f, yeah, all the way to infinity. So this will also be from 0 to infinity. So x would be an element of negative infinity till 1, okay, and from 0 all the way to infinity. So that's the entire solution there. Or you can say x is less than 1, all right, or x is greater than 0. That would be in inequality form. Right, now let's go to the next portion, guys. They say determine D and Q. So D and Q, so firstly, we've got the point 0 and 0 that g of x is passing through. So g of 0 would be d raised to the exponent 0 plus q. This is equal to 0. So anything to the power 0 is 1. 1 plus q is 0. And so q would be negative 1. Now to find the value of d, we're going to say g of x. That means this is equal to d raised to the exponent x minus 1, okay? But we've got the other point, which is 1 and 2. So when x is 1, okay, d raised to the exponent 1 minus 1, y is actually equal to 2. So d minus 1 is equal to 2. So d is actually equal to 3. Right, so the equation there. Right, so we found d equal to 3 and q is equal to negative 1. I hope that made sense, ladies and gents. Right, now as we go to the next one, so they say to us, determine the inverse of g, right, in the form y is equal to. Now, we know the new formula for g of x is equal to 3 exponent x minus 1, right? So we can write this as y is equal to. But remember, when I take the inverse, for the inverse graph, that would simply be x is equal to 3 to the power x, to the power y rather, minus 1. So we need to turn this into something that has y is equal to. So let's take the 1 to the other side. So that's x plus 1 is equal to 3 raised to the exponent y. Now, ladies and gents, remember this is where we introduce logs. Okay, so means the log of x plus 1 would be equal to y log 3. And if we divide both sides by the log of 3, log 3, right? That means the equation is y is equal to log base 3 of x plus 1. Remember, if I say log x plus 1 divided by log 3, I can actually express it this way in terms of logs. So we know the answer there. This would be log the base of 3 of x plus 1. Right, now they say to us, state the domain of the inverse of g. Now, remember that the domain of the inverse of g would be the same as the range, right, of the original graph, which is g. So what would be the range of g? So remember, our equation told us that g of x actually has a minus 1 there. Okay, let me just remove this entire thing. So which means this is an exponential graph that is shifted by 1 unit down, right? So which means it has an asymptote at minus 1, right? And it goes all the way to infinity, okay? So that is the range of g. But that means, so if we're looking at the range of g, it means y is an element of negative 1, actually, excluded, all the way to infinity, right? So that means also for the domain of g, x will be an element of negative 1 to infinity. Okay, right, I hope that makes sense, ladies and gents. So they say determine the A, B, and C. Right, now we've got our x-intercepts already, ladies and gents, right? So what I'm going to do is I'm going to say y is equal to A into, that's x plus 3. Note that I had an x-intercept at -3, but when I put in the brackets, then I have to change the sign. So that's x plus 3 as well as x minus 1. So now if I look at that, right, how would I get the value of A in this case? Now we can substitute for any other point that we know. And I know that when x is 0, y is 6. So I'm going to say 6 is equal to A to 0 plus 3 and 0 minus 1. Okay, so this would be A, that's 3 times -1, that's minus 3, which is equal to 6. And if I divide both sides by -3, I get A is equal to -2. All right, now there we go. So we've got the value of A. Now we can find all the other values. So which means this is y is equal to -2 into x plus 3, x minus 1. Nothing wrong if you decided to substitute there. I mean, you already know that the C value is 6, and you can actually just substitute. But I chose this route. Okay, so that will be x squared, x times x. I'm working inside the bracket. We've got 3x and minus x, which is going to give me plus 2x minus 3. But then if I multiply the -2 in, that would be -2x squared minus 4x plus 6. All right, and that is that means that the value of A is -2, and the value of B is -4, and the value of C is equal to 6. Right, and as I said, you could have actually chosen a different route of doing this. Or you could have actually used the fact that, so we know already that it's going to be ax squared plus bx. Our y-intercept is already 6, so we can put the 6 there. And you can substitute the values. Firstly, when x is 0, you know that y is, or rather when x is -3. So that's 0, that's A, that's 3 squared plus b times 3 plus 6. So you can do that and find and solve for A and B simultaneously. You've got 2 points, and so you can solve simultaneously. Now, they say to us, draw the graph of the inverse of f, right? Show the turning points and the intercepts. So guys, we just need to always be mindful when we are drawing the inverse, right? And this is the inverse of a parabola. Okay, so which means everything that happens on the x, on the original graph, happens on the y, right? So remember I had x is -3 here. That means our graph is going to pass through y is -3. And we have also x is equal to 1, right? So that means this graph is going to pass at 1. Y is equal to 1. Okay. And now we also had a turning point in this case. Our turning point, they said show the turning point and the intercepts. So our turning point here was at -1. You remember we found it earlier, right? And in fact, in my solution, I was supposed to say -1 over there. Okay, let's write it nicely. So this is from -infinity to -1. Okay, so in this case, I do have a turning point at -1. We just never got the value, the y value of our turning point. So y turning point would be equal to, so if we said that's -2 into -1 squared minus 4 into -1, okay, plus 6. Okay, so let's find that y value there. Okay, I get a value of 8, so which means this is 1 and 8, -1 and 8. Now, ladies and gents, that means that now for the inverse graph, it will have a turning point at y, or rather x is equal to 8, right, somewhere there, and y is -1. So let's put it over there. This is 8 and -1. Remember that they swap signs, okay? And what we also said is that it's going to pass, our graph passed through 0 and 6. This one is going to pass through at x is 6, y is 0. So this is what your graph of the inverse of the parabola would look like. Now they said we must label, so this would be 0 and 6. This would be y is, or rather x is 0 and y is 3. Actually, this is 1. And here we've got 0 and -3. Right, I hope that makes sense, ladies and gents. Right, so that's what our graph would look like, the graph of the inverse. All right, and finally, they say determine the values of k for which f of x plus k, so meaning we are shifting the value, rather the graph of f, right, such that it would be equal to g of x, right, has two equal roots that are opposite in sign. All right, now where are the two graphs equal to each other? Okay, and if you don't mind, I'm just going to remove the graph there. Okay, hope you were able to follow it. Right, now I want my graphs, okay, to be equal to one another at 2 points, but the 1 point must be positive and the one must be negative. So I see if I can shift this graph down and put it over there, what begins to happen? Yes, they still touch one another at 2 distinct points, which is, okay, I'm going to indicate them in blue, which is here and over there. But you see the one part is that it's 0, and the other part is actually negative. Actually 0, right? So this part is where they meet one another. The other part they meet at the origin, right? But now I don't want it to be, the roots should be definitely opposite in sign. So which means f of x must be lowered to the point where it gets to the origin, right? But if it passes that point, if we lower it any further, then we will start having them equal to each other or intersecting at 2 points that are not opposite in sign, right? So which means that k must be any value, right, that is greater than 0, but we must not be, k must not be actually, and we must not take it down by 6 units, right? So we're going to say k is an element of, right, so we can take any value going down, right, from So it must not be less than -6. So it must be greater than -6. Okay, but it must be less than 0. Okay, right, so any value from 0, right, if we take it down to -6 in this case can suffice. We can take the graph down until 6 units. Right, and so that is really how the cookie crumbles, ladies and gents. We're leaving it here, 23 marks, and really functions does count quite a lot, and please do focus quite a bit on it in preparation for paper 1. All right, guys, let's go into question number 6.